For these few examples, we're going to continue to introduce how we would work with these circular definitions of the trig functions. So once again, these problems assume that we know those circular definitions. Maybe you call them the XYR definitions, depending on what your primary source was. So in this problem, let theta equal 3 pi over 2 radians. Find the values of the trig functions of theta. So in this particular case, I know my actual angle. So I can draw it out in standard position. My initial ray and a terminal ray and an amount of rotation. That's what an angle of 3 pi over 2 radians would look like. From here, when dealing with the circular definitions, I'm really concerned about 3 values: the value of x, the value of y, the value of r. What x, y, and r am I talking about? Well, I would choose some point. I need some point on the terminal ray x, y that would intersect with some circle that would give us the radius of the circle there. Now, for this particular case, what we call a quadrantial angle, when the terminal ray is on an axis, I know a couple of things. I know more about x, y than just that it's some point with an x-coordinate and a y-coordinate. I actually know that the x-coordinate is going to be 0. So I can rewrite my point x, y as 0, y, and fill in my value of x as 0. The other thing that I know is that r and y are opposite values. Now, how do I know that? Well, the radius is simply going to be the distance from the origin to the point. And it just takes into account you measure the distance. Whereas the y-coordinate measures that same distance, but it also takes into account the direction, the fact that it's going down and moving in a downward direction. So those are going to be opposites. So that's the note I'm going to make here, that these are opposites. And once I have that information, I actually don't need to know any specific points. I could choose specific points and set values for x, y, and r, but I don't necessarily need to. I can work more generally. So sine of 3 pi over 2, the sine function defined as y over r. And I know that y and r are going to be opposites. So that would simplify to a -1. Cosine of 3 pi over 2, defined as x over r. But I know that x is 0. That would give me 0 over r. And it doesn't matter what r is. As soon as I have a 0 in the denominator, the whole fraction has a value of 0. Tangent of 3 pi over 2, defined as y over x. And here, I do know that x is 0. And you can't divide by 0. So tangent of 3 pi over 2 is undefined. It's a domain restriction. Then as far as reciprocals go, cosecant of 3 pi over 2. The reciprocal of -1 is 1. Secant of 3 pi over 2. The reciprocal of 0 will be undefined. A fraction has a 0 in the numerator and something in the denominator. If you take the reciprocal, now you've got 0 in the denominator, so we're undefined. And cotangent of 3 pi over 2. When we found the tangent value, we had a 0 in the denominator. Take the reciprocal, that 0 is now in the numerator, and that's now calculable, and I can get an answer, and I'll have cotangent of 3 pi over 2 equals 0. So just an example of how we can calculate the trig values of quadrantial angles if we don't have specific points. So that's okay, so we can still do that. All right. Second case, we're just going to be dealing with the signs of our values. Now, that's the SIGNS signs of our values. So this says if cosine of theta is positive and sine of theta is negative, in which quadrant does the terminal ray of theta lie? So we're just going to work through a logical progression of thought here, that cosine of theta is defined as x over r. And we were told that cosine of theta is positive. So x over r will only be positive if x is positive. We don't have to worry about r because r is a radius and r is always positive. And so then x is going to be positive in the first quadrant and the fourth quadrant. I mean, that's where our x coordinates of points are going to be positive for our terminal rate. We'll work through the same idea for the sine function. Sine of theta defined as y over r. And we want sine of theta to be negative. So we want y over r to be less than 0. Y over r, it's a fraction. R is always going to be positive. So y over r will be negative only if y is negative. And where on the coordinate plane do we have negative y coordinates? Well, we have negative y coordinates in quadrant 3 and in quadrant 4. So I look at my results. Sorry about the bell there. I look at my results and I see that the only place that fulfills both conditions is quadrant 4. So I can say that theta is a fourth quadrant angle. Now, I don't know if it's a positive angle or a negative angle or anything like that. That's just as good as I can do that. One last example here. If sine of theta is 3/5 and tangent of theta is negative, determine the values of the other trig functions. Now, we need that extra piece here because if I take a look at the sine function, sine of theta equals 3/5. Now, we know that this 3 is going to be a y-coordinate, and that 5 is going to be the radius of the circle. The problem is this y-coordinate, I don't know if that y-coordinate is from a point that is in the first quadrant where y's coordinates are positive, or the second quadrant where y coordinates are positive. So that would become important because I also have to figure out what is my value of x. And if if theta is a first quadrant angle, then my x would also be positive. But if my theta is a second quadrant angle, then this x is going to be negative because in the second quadrant x is negative. So I have to figure out which of these two quadrants I'm working in. And to do that, I'm going to use the tangent function information that was given. So tangent of theta needs to be negative. Tangent is defined as y over x. Well, that would be negative if x and y have opposite signs. If both x and y were positive, tangent would be positive. If both x and y were negative, a negative divided by a negative is a positive. So I need x and y to have opposite signs. And that occurs in quadrant 2 and in quadrant 4. So I'll notice here that that fulfills quadrant 2, quadrant 2. So now I know my theta is going to be a second quadrant angle. So now I can go ahead and draw a picture and figure out my values of x there. So a quick draw. Angle and standard position for a second quadrant angle. Some point here that is going to be x comma 3 with a radius of 5. I can put my circle in there. So I can use my standard equation of a circle centered at the origin. X squared plus y squared equals r squared. X squared plus 3 squared equals 5 squared. So x squared equals 25 minus 9. So x is going to be negative 4. Well, it's really going to be plus or minus 4, but I'm going to take the negative 4 because I'm in the second quadrant. All right. So now I've got my value of x, I've got my value of y, I've got my value of r. I seem to be running out of space here, so I'm just going to flip to a fresh slide here and write that stuff down, that my y was equal to 3, that my x is equal to negative 4, and then my r was equal to 5. Now I just apply the trig function definitions. Sine of theta is going to be 3/5. That's what we were given. Cosine of theta is -4/5. Tangent of theta, defined as y over x, would be -3/4. Cosecant of theta, reciprocal of sine. Secant of theta, reciprocal of cosine. And cotangent of theta, reciprocal of tangent. So just a few examples to get you going to work through for some problems, starting to use and get comfortable with the circular definitions of the trig functions. Hope you found it helpful. Thank you.